Welcome to Astro Science Academy, and in this video I'll be showing you guys on how to solve questions based on momentum, right? So now question 4 says that a delivery vehicle of a mass of 5,000 kgs, right, moving at a velocity of v to the right, collides head-on with a car of a mass of 2,000 kgs moving 30 meters per second, right, in the opposite direction. So immediately after the collision, the car and the truck move at 10 meters per second and 6 meters per second respectively to the right. So now let's understand two things, right? So before we answer anything, we need to analyze the information that's given, right? So we're going to say data given, right? So there are two parts that are happening over here. So before the collision, right? And then we also have after the collision. So let's understand that. Let's analyze the information that's there, right? So now, before the collision, and after the collision. So let's underline over there. Yeah, got that. So now, before the collision, we had mass of the vehicle, right? So you can call that mass V, right? Mass of the vehicle before the collision, it was 5,500, right? And it was moving, so its velocity of the vehicle initial, we're gonna call that velocity of the vehicle initial, we're just gonna say that unknown, right? And it was moving to the right. So the other important thing over here you need is direction. So since it was just an horizontal motion, we're just going to say that to the right to be positive and to the left to be what? Negative. So it was moving to the right, so that's going to just take it to be positive. Collides head-on with the car of a mass of 2,000 kgs moving 30 meters per second in the opposite direction, meaning it's moving to the left, right? So now mass of a car, right? Mass of the car, this is kgs, which will be 2,000 kgs, right? And velocity of the car initial, which will be 30 meters per second to the left. So we're going to make that to be negative, right? So now same thing over here. So mass of the car after also remains the same. The mass remains the same. V velocity of V final. They said over here that the car and the truck, right, move 10 meters and 6 meters respectively to the right. So the car and the truck and the vehicle move in the same direction after the collision, right, to the right. So now they said respectively, that means the velocity of the car after is 10 and the truck will be 6. So that's how we're going to analyze, right? So velocity of the vehicle or the truck, right, we're going to call that 6 meters per second, right? And the car will be, so mass of the car, which will still be 2,000 kgs, and the car velocity of the car final, which will be 10 meters per second. So this is how you analyze the information, always, to avoid confusion. You always do that, right? So now for 4.1 now, right, let's start. So 4.1 tells us that state the principle of conservation of linear momentum in words. So pretty sure you guys are capable of answering that, right? So now we know that the total linear of momentum in an isolated system remains constant, or you can say it is conserved, right? So we can leave it like that over here, right? So we know the total linear momentum in a closed or isolated system remains constant or is conserved. We can use that, right? Or you can put in your own words, that's fine. So now 4.2, calculate the magnitude of the velocity of the delivery vehicle before the collision. So they want to know the velocity. So they want to know this velocity over here. So now, here, since we already know that the principle of conservation of linear momentum over here is conserved, right? We are just going to say that the momentum, the sum of momentum before the collision will be equal to the sum of momentum after the collision. So now we're going to have mass of the vehicle times mass of its velocity, right? Initial plus mass of the car times the velocity of the car initial will be equal to the mass of the vehicle times v final, right? Plus mass of the car times velocity of the car final, right? And then once you're done, you just substitute in, right? So mass of the vehicle is 5,000, no, 5,500, right? And then the velocity, which is unknown, so we're looking for that, right? So we can just say we can just leave it as it is. We can just say v initial, right, plus mass of the car, which is 2,000, and the velocity of the car just moving in the opposite direction, so it will be negative 30 is equal to mass, which is 5,500, close bracket, v final, which will be 6 plus mass, which is 2,000, and this will be what, 10, right? So now once you're done, we can start to simplify now, right? So now you can take out your calculator, you can leave it over there, put it over there. Now let's start simplifying. So now 2,000 times negative 30, right? So that's negative 60,000. So now you'll have 5,500 v initial, right? And then this will be minus 60,000, right? Which will be equal to, so now let's work with the other part on the for after the collision, which is 5,500 times 6, close bracket, plus 2,000 close bracket, times it by 10, which will be equal to 53,000. So 53,000, and then we're going to transpose the 60,000 this side, becomes positive, right? So now 5,500 v initial is equal to 53,000, right, plus 60,000, and 5,500 v initial, which will be equal to, now let's add that together, plus 60,000, and this will give us 11,300. Now let's divide that by 5,500, divide that by 5,500. This cancels out, that cancels out. So v initial is equal to, so now we are going to take 11,300 divided by 5,500. So now we're gonna have that. So our final answer will be 20,54 20,54 meters per second, right? So we need to indicate direction also. So now you're gonna say v initial is equal to 20,54 meters per second to the right, because the answer came out to be positive, to the right. And that would have been our answer for that, right? So now let's have a look. So now for 4.3 says that if the collision lasts 0,2 seconds, calculate the force the car exerts on the delivery vehicle during the collision, right? So now they want you to calculate the force of the car exerts on the delivery vehicle during the collision, right? So now we're just going to say F net over here, because we know our formula, right, to get force, right? So F net will be equal to change in momentum all over change in time, right? So now let's open this formula again. So now we know that change in momentum can be written as mass all over v final minus v initial all over change in what? Change in time. So now mass we can use the car, right? Let's use the car. So now car will be 2,000. So 2,000 all over v final. So v final in this scenario is 10, because we got it over here, right? It's 10, right? So 10 minus open brackets negative 30, because that was the initial, right? All over changing time. So changing time, they told us it lasted for how long? 0,2 seconds, right? So 0,2 seconds. So we're gonna write here 0,2 seconds, and then once we're done, now we can just say, we can put this in our calculators now. So you can say fraction 2000. No, that's 20. All right, 2010 minus open bracket negative 30, right? Close bracket all over 0,2. Then you're gonna say, now your answer will be 400,000. So now that's 400,000 newtons, right? So that's our force. And then you're gonna come down to a conclusion. Now you're gonna say F net is equal to 400,000. Remember to indicate direction also, newtons to the, because it came out to be positive, so that will be to the right, right? And that is our final answer. Right, so guys, this is how we will be answering questions based on momentum. So remember, the key point is always to analyze your information, right? That's the most important thing. And also direction. Direction is very, very important. So thank you guys for attending, and I'll catch you guys next time. Take care.